Can you see my screen now?
Yes.
Okay. I'll get started. So last time we was talking about the extraction of metals. I draw you the table, right? So basically, you can base on the table to understand like which metal can be extracted using which method. Um, okay, so can you tell me some of the way that we can extract the metal?
Uh, Electrolysis.
Mm-hmm.
Uh,
Electrolysis, there are two way for electrolysis. We have electrolysis in the solution and electrolysis, but in the molten state. Or what else?
Displays reaction and reducing agent.
Mm-hmm. The replacement reaction, yes, replacement reaction, and the last one is reducing reduction reaction. Okay, all right, good. So these are like four of the method that we usually use to extract the metals. Okay, so for electrolysis in solution, like what is the condition, or maybe like can we apply this method to which metals
Uh,
in solution?
in molten state, it should be metal before zinc,
Hmm.
and uh, usually it will form the oxide, metal oxide, and chloride salt.
Hmm. Okay, we apply to metal before things. Okay, that's correct. Well, actually, for the electrolysis in molten state, we can basically apply to all the metals, but we usually save this one for the metals that are hard to extract. Okay, we can apply it to the other metals as well. That is just that we're gonna save this one for the hard metals, not for the metals that are hard to extract, because this method is very expensive. Because we have to melt the metals. Oh, sorry, melt the compounds, right? So it's pretty hard to extract. So you usually save this one for the metals before zinc, but we basically can apply to the other metals as well. It's just that it's not going to be economical, right? For the electrolysis in the solution, and we have the um, this one can also be applied to the reduction reaction. All right, we have the option from zinc to uh, we have from zinc onward. Okay, zinc to copper, and also we can also apply the same range from zinc to copper for the reduction reaction as well. Okay, so can you name me some of the reducing agent that we're gonna use for the reduction reaction?
Uh, it will be hydrogen,
Hmm?
carbon monoxide, carbon, and aluminum.
Aluminum. Yeah, aluminum. Sometimes we can also use magnesium. All right. So after the reaction with the oxide, all right, will be able to be these compounds will be able to reduce the oxide. So basically, hydrogen will be converted to water, carbon will be converted to CO into CO or CO2. CO will be converted to CO2, and aluminum or magnesium will be converted to aluminum oxide or magnesium oxide. Okay. And can you tell me the principle for the replacement reaction to extract metal?
Um, so from magnesium to the AN, the metal cannot react with the cold water. Um,
Hmm? It's from where to where? Can you say it again? Well, like which what is the range of application?
From magnesium
Mm-hmm.
to
Correct.
I don't remember the name.
Uh, Onward from magnesium onward. Okay. Okay, that's correct. We're gonna start from magnesium onward, and basically the application domain for this one is we're gonna have the metals that cannot react with water in at cold temperature. Yeah, you are correct. Very good. I'm glad that you did review the note, right? So you need to have something that cannot react with water at cold temperature because otherwise you're gonna have the reaction at cold temperature. Uh, um, um, Otherwise you're gonna have a reaction with water instead. Okay, so magnesium cannot react with water, and from that point onward, you just have the replacement reaction. Okay, let's move on to um the next part. So last time we were talking about the extraction of iron, right? So I told you some of the materials that we need for the extraction of metals. We need carbon, we need coal, we need carbon, we need iron, ions in the form of uh, hematite, right? Hematite is the oxide form of iron, which is Fe2O3. We have the coke, and we have the we need to have the air, the hot air, right? So you can review some of the reaction uh regarding these ingredients, all right, and the principle of how to extract the metals. Okay, so I'm not gonna review these reaction. They are already in the note. Okay, hopefully that you still have it. Do you need me to kind of review how we extract the irons here, or it's good to go to the next part?
I'm good now.
You're good, right?
Yes.
Okay.
Yes.
Okay. So all right, let's move on. If you okay with this one, so the next thing that I will quickly talk about is the metal waste. All right. So basically today we use metals a lot, and basically if you just like throw away the metal, it's gonna be really wasteful because we we have a limited amount of metal and we just extract a new one, so it's going to be really wasteful if you just throw away. So there's going to be one process to recycle the metal, all right, to recycle the metal, and we're going to have the reaction. Basically we're going to have some process to kind of purify the metal and then extract the metal again from the waste, all right. So next, okay, that's it for the metal weight. You it's just like a it's not really a important part. So I'm gonna move on to the next part, which is the metal corrosion. Um, After a period of time, so steel will become rusted. All right, the rusting process is very serious for iron. Okay, rusting can happen uh for many elements, not just iron, but iron is gonna be the easiest one to get rusted. All right. So when we talk about rusting, you need to understand that rusting is the process of converting iron or its corresponding steel. Steel is the alloy of iron, right? Uh, into the oxide of it, right? Into the oxide. Um, the oxide is mainly iron three, not iron two here. Actually, the iron three. Can you help me change that? All right. Rusting is uh the slow reaction. Sometimes it's fast, but like usually still take time. So it's a process of converting iron and steel into hydrated iron oxide okay, into hydrated iron oxide. And this is serious process because rusting will destroy the structure of metal. All right. So when you think of iron metal, when you think of steel, the metal and steel, which is the alloy, they are really stable. They are really hard. But when you see that when you see that we have rusting, it will change the structure. Um, the layer of rusting will be kind of flaky. All right, it's kind of flaky uh and it will be turned into flaky. Uh, it's going to be turned into flaky layers of rusting, and it will go out of the structure of the metal. And then if you keep having rusting, it will eat into the it will eat up the structure of the iron. Okay, so because of that, you can think that if you keep having rusting over time, it will completely destroy the structure of the iron, right? It will destroy the structure of the iron, right? Because you keep have the reaction, you keep having the same reaction, and it will make the flaky layers of rusting, and uh that layer will go away, and then the next layer of iron will be rusting. It will rust, and then you will lose the metal. All right. So basically, um, every year we lose a lot of money because of rusting. All right, because you need to replace um, the part, that part in the machine or something like that. All right. Um, so when you have rusting, remember that's gonna be for iron and steel, and there are two conditions. Yeah, there are two main conditions for rusting to happen. We need to have water. All right, we need to have water, and we need to have oxygen. Okay, these two conditions must must be present at the same time. Okay, sorry, present, not present. Present, yep. These two compounds, sorry, these two substances must be present at the same time, water and oxygen, so that rusting can happen. All right, you can kind of imagine like this. Rusting is the process of turning iron, the iron part in the alloy or the iron metal, right, with the help of oxygen in the air, or maybe in oxygen and water, and will slowly be converted into iron 3 oxide, the hydrated form of iron 3 oxide. Okay, there's one more condition that is not compulsory, but it will speed up the rates of rusting. All right, when you have electrolyte, it will speed up the rate of rusting. This condition is not compulsory. It's just like it will speed up if you have electrolyte in the solution. It's gonna speed up the speed of rusting. Okay, that one is not really compulsory, but it will change the speed of rusting. All right, and we actually have an experiment to kind of like prove that oxygen and water must be uh, present at the same time for rusting to happen. Okay, so we have this tube, test tube. Okay, we have this test tube, and then we put a cap on so that it will trap the air inside, and you put it in water. All right, you put it in the still water, and you can see that rusting will happen. Okay, and then we're gonna repeat the same reaction in tubes two, but this time you're gonna put it in calcium chloride salt, but like in the solid form. Okay, it will absorb all the moisture inside. All right, we just have dry air, but we don't have water because all the water is absorbed by anhydrous calcium chloride, which is a solid and it will absorb all the moisture. Therefore, we don't have we just have oxygen in the air, but we don't have um, H2O in the solution, and therefore we have no rusting. You can see that the metal is still the same. Okay, we repeat the reaction, but this time we have no oxygen, but we have water. Okay, we can prevent the present of water in the solution by adding another layer of oil. Okay, above the water. So basically, we submerge the iron into the solution, but then we add oil on top. So oil will prevent the oxygen from getting into the water. Okay, it prevents the oxygen in the air from getting into the solution, and therefore it cannot contact the metal down below. Therefore, um, we can also like eliminate the oxygen by boil the water before we use it. And basically, when you boil the water, the solubility of oxygen will decrease and it will eliminate all the gas out of the solution. Okay. And then you see no rusting over here. And then the last experiment, instead of using the air, you use pure oxygen. This is to prove that oxygen in the air is the main culprit of bursting. All right, maybe when you have the air, we can also have the other gases. So we use pure oxygen for the last experiment. All right, so we have oxygen and we have water over here in pure oxygen. Okay. So they are like the set of four experiments, right? The first experiment is to have the water and the oxygen in the air normally. You see rusting, and then we change the reaction. We eliminate oxygen or we eliminate water, and then we have two more test tube, and the last one is to use the same thing as the first one, but instead of the air, we use oxygen to prove that it's actually the oxygen in the air that is responsible for rusting, and then we have rusting again. Okay, so that is to prove that water and oxygen must be present at the same time. Um, must be present at the same time for rusting to happen. All right. Okay. I'm gonna give you like some minutes to take note over here, and then we're gonna come to the next part, which is the part where we talk about some of the way that we can use to prevent the rusting process. You can still see my screen now, right?
Yes.
Okay. All right. Let's move on to the next part. So there are some ways that we can prevent rusting. All right. We're gonna uh start with painting. All right. So painting is like you add another layer. Um, you add a layer of paint on the surface of iron. So can you explain why do we do that? All right, how can that prevent rusting from happen? You can basically base on the fact that we need to have water and oxygen at the same time for rusting to happen, right? So think of a way that painting can help us um, to prevent rusting.
It will
It will
have
eliminate
barrier
which,
to
yeah, yes, continue.
it will eliminate oxygen.
Yes, it will create a barrier to kind of like isolate your iron from oxygen, right? It can also eliminate water if you want, but usually it will create like a physical barrier to kind of isolate your iron from oxygen, and therefore rusting cannot happen. All right. However, this cannot prevent rusting if the paint is scratched. Right, you can imagine like if the paint is scratched, you can your iron will be exposed to the air, and the iron being will start to rust. Right. So therefore, with this method, we will check the condition regularly, and then we need to repaint. All right, we need to repaint the object regularly to make sure that is in good condition. All right, so that's the first part, hinting. All right, you can see that people usually paint the ship a lot, right? Because the ship is usually made of made up of iron, and we need to paint the ship regularly to make sure that um, we kind of isolate the air, right? Isolate the ship, the iron part from the air. Okay, and the ship for the ship, you're gonna see that we actually have many different methods at the same time to prevent the ship from rusting. All right, not just painting. Painting is just one of the methods that we use for the ship. For the ship, we actually combine three or four different methods because the ship are large and they're usually made of iron for the whole ship. Okay, and if you have any kind of damage to the iron in the ship, it will sink the ship. All right, so they have many different methods to prevent rusting for the ship that we're gonna talk about later. Okay, and this is just one of them. All right, let's move on to the next one. Um, the next one is also the same. Instead of using the painting, you can prevent rusting by applying the oil or greasing onto the steel and iron part. All right, still the same. All right, it will basically prevent them from contacting the air and moisture. All right, it's still the same. It's just form a physical layer. All right, a physical barrier layer, exactly like painting. But instead of using paint, I use oil and grease. All right, basically the same principle. Also the same as coating with plastic. Um, also the same, right? When you coat it with plastic, it also create the um, the outer layer, um, the physical barrier that will isolate the iron from rusting as well. So basically, for the first three method, painting, oiling, greasing, or coating with plastic, they create the physical barrier. All right. So we're gonna come to the next part, um, which is galvanizing and sacrificial protection. Galvanizing, uh, galvanizing and physical protection, sacrificial protection. They are like two chemical methods. All right. For the previous three methods, they are physical methods. We use the physical barrier to isolate the metals from uh, being exposed to the air or being exposed to the gas. Um, but for galvanizing and for sacrificial protection, we use a reaction. Okay, let's talk about galvanizing first. Okay, so uh, galvanizing is the process of dipping the object into molten zinc. All right, it is going to be dipping the object into molten zinc, and sacrificial protection is also the same thing, basically the same thing, but instead of like dipping the object into molten zinc, we use a zinc bar. All right, a zinc bar is like, okay, let me see. All right, this is the zinc bar. All right, so basically this is the method over here. You can see this is the method of sacrificial metal, and uh yeah, you have the zinc bar here, or maybe you dip the whole sheet to coat a small layer of zinc onto the surface. It's going to be called galvanizing. Okay, they are essentially the same thing. It's just that there are two ways to introduce the zinc onto the surface of the iron. There are just two ways to introduce, and and with this method, they are kind of special because even when you scratch away the layer of zinc, all right, even when the zinc cannot fully cover the ship, you can still like you can still basically protect your ship. um, let's think about the reactivity series, right? You remember that for the reactivity series, zinc is going to be more reactive than iron, right? Do you remember that? Okay, zinc is going to be more reactive than metal. Sorry, than iron. So basically, zinc will react first. All right. This is going to be the reaction where you oxidize the metals. All right. So the metal that is stronger, that is more reactive, will react first. All right. And whenever you have zinc, all right, whenever you still have zinc, zinc will react first, and it will sacrifice to be destroyed first instead of iron. And therefore, if you need to just add like the you need to add like the zinc bar onto the surface of the iron, or maybe you still have zinc somewhere that is attached to the machine. Zinc will be oxidized first, right? Zinc will be oxidized first, and therefore will be able to protect the the ship. All right. But here's the thing. There's one downside of this method. All right. Can you guess what it is, Anthu? There's one downside to this method. Can you keep like protecting the iron forever? What is the limit? Like, what is the limitation of protection?
Uh, it will be like it's just in the short period.
Short period. Why?
Because it will get use of it. Like
Yeah, like use
get
up
rid.
the zinc, right? We
Yeah.
use when you use up all the zinc, it will not be able to protect the iron anymore. Okay, that's good. All right. So for these two methods, well, actually, it will be the limitation. The downside is that it's gonna not gonna be forever. All right. When you use up the zinc, when you need to replace it with a new one. All right. So basically, you will waste zinc in into the process of protecting iron all the time. So regularly, you need to replace the zinc bar. All right, buy the new zinc bar and install them onto the ship or something like that. Or you need to galvanize the ship again. All right, to make sure that you have a new layer or the new zinc onto the surface of the iron. Got it? So basically, that is the downside of this method. But this method is good. It's a bit better than the other previous method because if you scratch out the layer of zinc, you can still protect the iron. All right, because basically, when even when the iron is exposed to the air and water, when you have zinc, zinc will be always zinc will only be able to react first before iron, and therefore zinc will sacrifice itself to protect the iron. Okay, we actually have one more method which is not mentioned here. Okay, I'm gonna write that for you. We actually have one more method. You're gonna see this method in the exercise, all right, in the homework. and that is the thing that we actually learned. We have electrolysis. Okay, that is electrolysis. We're gonna set up the electrolysis right onto the surface of the iron when you use the iron for your for your advantage. Like when you have the ship, right? We're gonna set up the electrolysis onto the surface of iron. Okay, so you can think of it like this way: when you have electrolysis, the reverse process will happen. All right, the reverse process will happen, and therefore, um, if you have the reaction to form iron 3 oxide, for example, it will reverse the process and prevent the rusting from happening, and therefore we have a reverse process from iron 3 oxide converting back to iron. All right, and therefore we prevent rusting. That is actually a very good method. I'm not sure why they kind of eliminated it from this book. Basically, from the previous book, we can still use electrolysis for we can still have that method in the previous part of the book. I'm not sure why they eliminate that part in this book. So yeah, that is electrolysis. So I'm gonna give you the example, right? Um, so for electrolysis, remember that the negative electrode is going to be the cathode, and the positive electrode is going to be the anode. Okay. So usually, when we talk about the oxidation reaction of iron, uh, we oxidize the iron. All right. So when we have electrolysis, iron will be the iron part will be reduced. Okay. So what is the iron part here? Um, so basically, if you oxidize the iron, it will become iron 3 oxide, right? And it will be reduced at the cathode. All right, you gain electron, and then you form iron again. All right, and the other at the other electrode, basically you 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 uh, you electrolyze water. Okay, like this. All right, like this, and therefore you can see that we will keep the iron as iron all the time. We cannot really oxidize it. All right, and that is the electrolysis. You're gonna set up the electrolysis right onto the ship. All right onto the machine, right onto the object that we want to protect, and we just use the electricity to prevent the rusting from happen. Basically, you're gonna provide the energy. So there's one advantage of this method electrolysis, which is that you don't have to waste the zinc. All right, what you need is to set up for electrolysis to happen. So as long you have the electricity, as long you have the electrolysis setup, you're fine. All right, and the downside of this method is that you constantly use the electricity to protect the iron. All right, you constantly use the electricity. So instead of the money you will spend on zinc, you use the money on electricity. That is the same thing essentially. Okay, so let's talk about, or I'm gonna give you some time to take note. So basically, there are some of the way that to protect the iron from rusting, and you need to remember some of them. All right, maybe um, sorry. So maybe you can have maybe you can have rusting. Sorry. Maybe you can have like physical methods like using the oil, the grease, um, the physical barrier to isolate the iron, the metal from rusting. Maybe you can have the chemical reaction like galvanizing, sacrificial protection, essentially the same thing, and electrolysis. Okay. All right, let's move on to another part, the corrosion part. So corrosion is basically the common term. All right, rusting is applied to iron essentially, but corrosion is a the term that is applied to metals in general. All right, so corrosion is like the process of um, uh, when you have metals and alloys that are attacked chemically, that are chemically attacked by oxygen, water, and many other substances like acid or something like that. All right. So rusting is the corrosion for iron, but corrosion is a general term for all the metals. All right. So remember that um, according to the theory of reactivity, we the more reactive metal will be able to react much better. All right. So metal of better reactivity will be corroded much so much more than the less reactive metals. But the less reactive metal can still be corroded to some extent. All right. All right. So for example, sodium and potassium, we need to store it under the oil because the oil will prevent the air, the water from corrode the sodium and potassium. All right. Um, aluminum is gonna be oxide. It's gonna be corrode. It's gonna be corroded a bit, and it will create a protective layer of oxide onto the surface, and that protective layer of oxide will protect the aluminum from getting corrosion anymore. Um, all right, I'm gonna give you one very well-known example of corrosion. Have you okay, what is the symbol of New York? Do you guys know what is the symbol of New York? New York City in the United States of America. All right, what is this? I'm gonna give you a hint. Like, um, let's see. This is actually a statue. All right. So can you think of like what is the thing that I'm referring to? Statue of what?
Of liberty.
Yep, Statue of Liberty. That is the symbol of New York, actually. Okay, why do I talk about this? Do you know the material that we use to make the Statue of Liberty in New York? Do you know
Is
what
it
is the?
copper?
Yes, go ahead. Yes, it's copper. All right, it's copper. What is the color of copper?
Uh, I don't know, but when it react with oxygen, it will form blue.
Hmm? It will form the color greenish blue uh color, right? Okay, so I want to bring that one up because copper of the Statue of Liberty has been oxidized by the oxygen. Okay, so because it was originally made of copper, so the color should have been brownish. Okay, that's the color of copper metal, right? You know the copper metal is the core of the electrical wire, right? Okay, that's the thing. But over time, copper will get oxidized and will be slowly converted into the greenish color of copper oxide and copper. Um, you basically the content of copper. All right, so it will change the color. Okay, so that's it for this one. Um, let's move on to the next part. So alloys. We talked about alloys before. Alloys is when you have the mixture, right? You have the mixture of metal and all the elements. All right. So why do we make alloys? Okay, we make alloys because they will have more useful properties than the corresponding pure metal. They can be harder. They can be more corrosion resistant than the metal. All right, sometimes they can be more flexible. Sometimes the melting point will be higher than the corresponding metal. All right. Okay, so we make alloys because they will possess some of the better useful properties than the pure metal. All right, so you can name them out like they're gonna become harder. For example, they will become more corrosion resistant. Sometimes is for the uh, appealing reason. All right, it's gonna make the alloy much better looking, right? All right, we're gonna have some example over here. So we have the brass. All right, brass is actually the mixture, the alloy of iron and zinc. All right. Um, sorry, a copper and zinc. My bad. All right, brass. You have the alloy brass. It's gonna be the mixture of copper and zinc, and that one is actually harder than copper itself, and it's gonna be more corrosion resistant. All right, brass harder, more corrosion resistant. All right, we can have steel. All right, steel. We actually have many different types of steel. Actually, we can mix carbon, we can mix the other metal into iron to create steel. But there is one class of steel which is very important, and we call that class of steel stainless steel. All right, have you ever heard of stainless steel before? Hello. Oh, let me check on Edward whether
Uh,
she's here. Okay, she's not here. Okay. Anton, have you ever heard of stainless steel before?
yes. Uh,
Yeah. Do, one of okay, one of the most important properties of stainless steel. What can you guess?
stainless steel. Uh,
It's gonna be resistant to corrosion. That is the most important thing of steel. Okay, the most important property of steel. All right, and how can we do that? We can do it because we can introduce nickel and chromium into steel, into iron. All right, to create stainless steel. All right, and the chromium is actually the part that will prevent steel from rusting. Okay, and nickel we make it harder. All right, so we can take note this one. You can take note like for stainless steel we're gonna add nickel and chromium into iron. Chromium will prevent iron from rusting. Nickel will make it hard. All right, let's move on to the next part. All right, next time I'm gonna have some question regarding brass or stainless steel. All right, I may ask like to make brass, what is the metal that we introduced to copper? You should be able to tell me that's zinc. All right, and it's gonna make the brass harder and more resistant to corrosion. I may also ask what are the metals that we add to iron to make stainless steel? They are going to be chromium and nickel. And what are the uses for these two metals, right? Okay. All right. Moving on, we have alloy to order. Alloy to order is like, you order the alloy from the manufacturers, and they're gonna make the alloy according to the properties that you want. All right. For example, like if you want your alloy to be like really beautiful, shiny on the surface with this color, they can make the alloy for you, all right, by mixing the metals together, but with different ratio, all right. So basically, for this metal, they can have 90% of iron, for example. For the other type of alloy, they can mix using just 80% of iron, and they will increase the percentages of the other metal, or something like that. So basically, not just about the ingredients, but also about the ratio. All right. When you change the ratio of metals in the alloy, you can actually change the type of alloy that you end up with. Okay. All right. That's it. Um, Sometime, by introducing another metal into the alloy, you can make the cesium, um you can make it like less malleable and ductile, all right, for the alloy. Usually the metal is going to be more malleable and ductile than the alloy. That is because, when you introduce, atoms of the different type, right? Like this. For example, like you introduce this metal into the crystal of the other metal, all right? And because they are of different size, they can not really slide over each other easily, like in the case of metal, and therefore it will make the alloy less malleable and ductile. All right. And down here you're gonna have some named alloy where you don't have to learn them by heart. You just need to take a look at, the name of the alloy and competition. I tell you that we can change the ratio, right? Even though you use copper and zinc, you can actually change the percentages of copper and zinc to make new alloy, and then you can tailor them so that they will have your desired properties. Okay. Okay, and that's it for this chapter. Do you have any other question regarding what we have just gone through? And then,
No.
okay, that's good. So basically, if you don't have any question, then let's move on to the question. So today we're gonna try to go through these questions. All right, we're gonna try to go through the question in book over here. So first of all, I want you to do the question number one and question number two. All right. All right. I'm gonna give you 10 minutes to do the question number one and question number two on your own. You can write down the answer in your notebook. All right. In the meantime, I'm gonna upload the homework for this chapter for you onto the drive. All right. So we're gonna come back at 8. All right. I guess start. If you have question, just tell me, all right? Can you see my screen? Is this too small for you?
I have a book.
Okay, that's good. You can use a book to see. Okay, in the meantime, I'm gonna upload the video for you. Oh, sorry, not the video, but like I mean the homework for you. Uh, methods. Okay, we're gonna start in the next 1 minute. All right, 1 more minute. All right, let's get started. So use the following list of metals to answer the question from A to I. Iron, calcium, potassium, gold, aluminum, magnesium, sodium, zinc, and platinum. Identify the metal that are found native. Can you tell me the metals that are found native? What are the metals that are found native?
It's gold,
Mm-hmm. Is there anything else?
platinum.
Yep, platinum, gold. Yep. Can you explain why?
Because it's down from the periodic table, not period
Reactive series, reactivity
reactive
series.
theory.
Mhm.
So
So,
it will not react with oxygen, so it will like pure metal.
yeah, pure metal. Okay, and doesn't have to be oxygen. It can be many other element actually. Okay, that's correct. Identify the metal that can be found as the ore of rock salt. Rock salt is essentially salt. So what's that?
Sodium,
Yep, sodium. How about bauxite?
it's aluminum.
Good. Metal in chalk.
Uh, Calcium,
Calcium. Yep. Metal that will not react with oxygen to form oxide.
platinum,
Uh, yep. What else? You for you like for this question you only need to list one, right? But like I want you to list as much as possible. How about gold? Yeah, we can also have gold over here, right? Identify the metal that will react violently with cold water.
uh, potassium,
Yeah. What else?
uh, calcium,
Mhm.
sodium.
Yeah, sodium, potassium, calcium is a bit controversial here. I mean, it can react with cold water. It's just that it's not gonna be violent. Okay, this is violent, so I think that I would not choose calcium, even though it can react with water. All right. So, can you help me write out the reaction between magnesium and water, like in the steam, at the steam, right? Water as a gas.
It will form magnesium oxide and hydrogen.
Magnesium oxide and hydrogen. Good. All right. Let's move on. Uh, choose one of the metal you choose in E and balance the chemical reaction. Okay, can you help me write down the reaction between potassium and water? Cold water.
Uh, it will form potassium oxide, hydroxide,
Huh?
and hydrogen.
Okay. And balance the reaction by putting number two before potassium water and potassium hydroxide. Identify which of the metal have the protective oxide coating on the surface.
Uh, is aluminum.
Yep. Reacts very slowly with cold water, but extremely vigorously with steam.
Magnesium.
Uh, Magnesium cannot really. Yeah, magnesium is correct. Usually, I will not classify magnesium as being able to react with water. However, we can have calcium here. All right. Magnesium is also correct, I think, but I would prefer calcium. Calcium can react with water, all right, with cold water, but extremely vigorous with steam. Which one of the metal is used to galvanize iron? We just talked about galvanizing, right? So what is the metal that you use to galvanize iron?
Uh, Zinc.
Zinc, that's correct. Zinc. All right, let's move on. Um, we have copper heat in the air to form black solid A, all right? So what is A?
Uh, A. Um, is
Is what?
uh,
When you burn copper in the air, what is the thing that you will get?
copper.
Hmm? Copper heat in the air, you form solid A. It's black. So what is A?
Copper oxide.
Yep, copper. No, well, what kind of oxide?
Copper 2 oxide.
Copper two oxide. And so it's going to be CuO, right? Exactly like that. And when you heat with powdered magnesium, carbon oxide heated up with um powdered magnesium, what's the thing that you're gonna get?
Magnesium oxide.
Magnesium oxide. Which one is that? The B or C? Which
Uh, is B.
brown pink solid is magnesium oxide. So what is
No,
C?
no. Is wrapping solid is copper and white power is magnesium oxide.
Okay, that's good. All right. So you have this reaction, right? So what kind? So what is this reaction? This is actually the reaction. What kind of method that we use to extract the copper over here? According to four methods that I introduced you.
Reducing agent.
Yeah, using the reducing agent, right? Using magnesium. Okay. So you see here, that is exactly the reaction that I'm talking about. All right, moving on. All right, we add these two compound into dilute hydrochloric acid, right? So copper cannot react. It will be copper over here. Colorless solution D. Can you tell me what solution D is?
Is it mm, magnesium hypochlorite?
What magnesium hypochlorite is ClO2 like this.
Uh,
What is the product between hydrochloric acid and magnesium? What is hydrochloric acid?
only magnesium.
Wait. What is hydrochloric acid first?
Hydrochloric acid is HCl.
HCl, okay. So HCl and you let react with MgO. What's going to be your product? The oxide react with acid.
Mm, it's magnesium chloride and water.
Yep, that's it. All right. What did you answer me? Magnesium hypochlorite. It's magnesium chloride, right? Okay. Okay. So you filter and evaporate the filtrate. Okay. What is the filtrate? And what is the residue after you let these two, you filter these two, this mixture with copper and magnesium chloride there? What is in the residue and what is the filtrate?
Uh, we will have uh, with the solid is magnesium chloride.
Magnesium chloride. Is that in the residue in the filtrate?
Is the residue.
Is a what is the filtrate and what? Okay, but imagine like when you filter something, what is going to be the filtrate and what is it going to be the residue? Like normally, what will be the residue? What will be the filtrate when you
Residue
filter? Right?
like it will be the bigger molecules of
Okay, here's the thing. When you filter, you're gonna have the liquid that is pouring down into the beaker down below, and you're gonna have some solid up to the top, right? Just above the filter paper. So what is gonna be the filtrate, and what is gonna be the residue?
uh, filtrate is water.
No, filtrate is like the thing that yeah, we do have water, but like it's gonna be the solution. All right. For example, like if you have sodium chloride, for example, sodium chloride solution, you will have sodium chloride that is dissolved, and we have water, right? So basically, the filtrate is gonna be sodium chloride solution that can go through the filter paper. All right, and the residue is basically the solid that cannot be dissolved in the solution. Okay. So you have copper, you have magnesium chloride, and you perform the filtration. So what is going to be the filtrate and what is going to be the residue, according to my explanation of what filtrate and residue are?
So copper it will be the residue and magnesium chloride is filtrate.
Mm-hmm. Okay, understand, right?
Yeah.
Okay, so you filter and evaporate the filtrate to um the dryness. So basically, solid D is coming from the filtrate. So what is solid D?
Is copper
Mm-hmm. No, filtrate. Like understand,
filtrate
right? Okay,
like
you perform the filter and you evaporate the filtrate. It means like you perform the evaporation on what? On the filtrate, right? You already eliminate the residue from the filter part. Understand?
yes. So it
So
is
yeah,
uh
it's the solid D over here. Like up here we have solution D. Now we have just a solid D, so it's still magnesium chloride. Understand?
oh
Okay. So basically, you filter and evaporate the filtrate. It means like you perform the filtration. You have the filtrate, um, the filtrate that can go through the filter paper, and you have the residue, which is the copper. All right, and you don't, you basically separate them to substances out of each other, and then you just dry the filtrate. All right, so we have magnesium chloride. Okay, so we perform the electrolysis on the molten magnesium chloride to have silvery metal E, and green gas F. So what is E and F?
In we will have magnesium as metal and chloride, chloride,
Chlorine, not chloride, right?
chlorine,
Yeah,
chlorine.
yes. Okay. And this is the molten electrolysis, right? Remember what is the applicable domain of this one? According to what I told you, what is the range of application of electrolysis in the molten state?
Before the zinc.
Yeah, before the zinc. Magnesium is before the zinc, right?
Yeah.
Yeah, so that is the reason why we perform the electrolysis of the molten state. Okay, so got it right. Let's move on to talk about the other thing. Give the name and the formula of the substance from A to F. So basically copper to oxide hydrochloride. Okay, so basically ignore that. Give the chemical equation. All right. So for the chemical equation, what is the chemical equation here that you have? Black solid A was formed. What is the reaction?
Black. Uh, it will be copper to oxide.
Copper to oxide. I mean like reaction. Copper to oxide is just one compound, right? I want to have the full chemical reaction.
Is copper to react with oxygen. It will form
Copper to or copper.
copper. Just
Yep, copper react with oxygen to form CuO, right? How to balance that reaction?
uh, we will have two before copper and two before copper to oxide.
Hmm. All right. Um. So, white powder C and brown pink solid B was formed. White powder C, brown pink solid B.
Uh,
Got copper oxide and magnesium, right, to form magnesium oxide and copper. Okay, that's it. Colorless solution D was formed. Why is D?
uh,
It's magnesium chloride, right?
magnesium chloride.
So we have magnesium oxide. Let react with HCl to form MgCl2 and water, which is the thing that we already wrote down. Um, the reaction between black 8 and magnesium is a redox reaction. Okay, so basically this is the redox reaction. Can you explain why this is a redox reaction?
Because in the reaction, the copper is lose the oxygen. So it will be the oxidation. Oxidation. Uh, and magnesium is gain no reduce. It will be the copper. It will be reduction. The magnesium it will be oxidation because it's
Oxidation
gain
or oxidizing agent. Oxidation or oxidizing agent. Which one is the one that are referring to?
oxidation.
Oxidation. For what? For what? For copper.
Oxidation from magnesium.
Mm-hmm. And reduction for copper oxide. Okay. Right. Okay. Write the anode and cathode reaction for the electrolysis of molten D. Anode. All right. When you perform the electrolysis on molten magnesium chloride, what is going to be the reaction at anode?
Uh, anode it will be uh chloride
Mhm.
Cl Cl two two Cl equals Cl2 plus two electrons.
Mm-hmm. How about cathode?
Cathode it will be Mg Mg2 plus two electrons, two for magnesium.
Okay, that's it. Suggest a use for browsing solid B, silvery metal E, and green gas F. Okay, suggest a use for this is copper, silvery metal E is magnesium, um, and green gas F, which is chlorine. All right, can you guess me a use for each of those elements?
Copper, copper it will be cable wire.
Mm-hmm. Magnesium.
Magnesium
Have you ever heard of like magnesium as the vitamin before?
vitamin.
Yeah, we drink magnesium as vitamin, right? Or we can also use magnesium in as like one type of medication, actually. Okay. How about the last one, green gas F? What green gas F is basically the chlorine, right? Chlorine, the use of chlorine. Can you name me? Yeah.
Is uh
We've learned chlorine before, right?
I don't remember it in English.
Uh, what in English? Like the use in English? You can
Yeah.
name the use in Vietnamese.
Thuốc tẩy rửa.
Oh, okay. So you can use it in the cleaning products. Okay. You can use chlorine in the cleaning product. Yes, that's correct. Is there anything else that you can remember?
Um, a form of the hydrochloric acid.
Yeah, to produce hydrochloric acid. What else? To for water treatment, right? Water treatment to kind of kill the bacteria. What else?
Can it like making the soap?
Making the soap. Yep. Mm, yeah, but like it was the use of sodium chloride more than chlorine actually. So, for chlorine, I think that you can talk about, making the polymer PVP or something, PVC, something like that, right? Polymer, the raincoat, the pipe, water pipe, or something like that. Okay. All right, that's good. Okay, let's move on to the next part. For the question number 3, we're gonna go through them really quickly. All right, explain why metals such as gold and silver occur native in the Earth crust.
Uh, because it not react with oxygen, so it will be inactive.
Yeah, not just oxygen. Okay, it can. Okay, it's not. Um. So basically, um, the native crust, it basically we don't have the reaction between the metal and the other elements, all right, not just oxygen. So it will why is that? And because they are they are less reactive, right? They are less reactive metals than the other metals, so they appear native in the Earth crust. Okay. Let's the next part. The parts of the shipwreck make up iron rust more slowly in the deep water. Why is that?
Uh, Deep water. Is the B?
B, yeah.
Uh, like because it's not appear the oxygen.
Yep,
So
we don't have the oxygen. Yep. The concentration of oxygen in the deep water is lower than the oxygen in the air. So basically, water is important for rusting, but it's also create a barrier to kind of isolate the iron from the oxygen. Okay, so yeah, it's because we don't have the direct contact to the. Uh, all right, can you wait for me 1 minute? Edward forgot that we had the class today, so okay, let's move on to the next part. Zinc bars are attached to the structure of oil rigs to prevent them from rusting, right? Zinc bar. Um, so this is the method of using sacrificial metal, right? Zinc is more reactive than metal and will be able to be oxidized when is introduced to the environment with iron. All right, it's more reactive, so it will be able to be oxidized first. Moving on, copper roots quickly become covered with green coating when exposed to the atmosphere. What is the name of this process? What is the name of the process of turning copper into the compound?
the the copper is react with oxygen.
Huh? What is the name of that process?
Oxidation.
Oxidation. Yep. Or maybe we can also use a term that we have just learned. What is that? What is the term that we have just learned?
Uh, Rustic.
Rusting. Oh no, no, rusting is only safe for iron, right? Um, we have corrosion. Corrosion is
Oh,
a term for the other metals. Recycling metals can save money. This is very straightforward, right? Because we already have metal, so recycle. We make sure that we use the metal waste and convert back to metal, so we don't have to actually go through the extraction process one more time. We just need to purify the metal, so it can save us a lot of money. Understand?
yes.
Mhm. Moving on to the next part. Iron is extracted from its ore, hematite and magnetite. Usually, it is extracted from hematite iron 3 oxide. When the ore is mixed with limestone and coke and reduced to the metal in the blast furnace, the following is the brief outline of the reaction involved. All right, so we talked about this one before. Can you name me the gas A? Can you tell me what gas X, gas Y, and so what is gas X and gas Y basically?
Get gas X. It will be carbon dioxide. Gas
Mhm.
Y is carbon monoxide.
Mhm. Cap carbon dioxide gas and coke gas monoxide. Yep. All right. Name the gases. Reaction. Name a chemical reaction to identify the gas X. Do you remember how can we confirm X is actually carbon dioxide?
Uh, Y precipitate.
Yeah, that's good. By precipitation of something. That's good. What is that?
Um,
What precipitation of what?
uh, is it mm, don't
Um,
uh,
that is when you use what kind of reaction that you use to detect the presence of carbon dioxide.
uh, reducing agent.
No, I mean, okay, we're gonna use calcium hydroxide, right?
Uh,
Why it's gonna be the reaction between we're gonna bubble calcium carbon dioxide through the solution of calcium hydroxide. Okay, we're gonna bubble this one through the solution of this one. What's gonna be your observation? Why precipitate of what?
uh, it will be white precipitate and
Of
uh,
what? Of what?
carbon. Mm,
I mean, like what? Why precipitation um, of what compound?
of carbon dioxide.
Carbon. This is already carbon dioxide, right? I mean, the name of the compound.
Carbon. Um, uh, cap,
Cal- Calcium
calcium,
carbonate.
calcium
Uh-huh.
carbonate.
All right, but if you keep bubble the CO2 into the precipitate, it's gonna dissolve the precipitate, right? Because you basically form calcium hydrogen carbonate, right? So this is another reaction. Basically, the observation is like this. You're gonna see this white precipitation that is formed, all right? And if you keep bubble the carbon dioxide into the solution, it will basically dissolve the white precipitation. Okay, it will dissolve the white precipitation. And we have the second reaction because this one, calcium hydrogen carbonate, is soluble in water. Okay, and that is going to be the chemical test for gas tanks.
Mm,
Okay, let's move on
yeah.
to. I think that we can take a short break of like 3 minutes. All right, you can go and drink water or something like that. We're gonna come back at 38. All right. Jeez. Choose the. All right. Until you told me that you're gonna have the exam, IGCSE exam in let me see in May, right?
Uh, like yes, end of May and like the first week of June.
The first week of June. All right. I think that we still have enough time to finish this one. All right. Have you finished the chemistry at school? Which part are you at school now?
Is I think uh about the environment.
Environment. So so this chapter, the next chapter, the chemistry of
Yes,
environment.
yes, yes.
Oh wow. So we almost catch up with what you're learning at school. That's great. Okay. All right. I hope that we can finish this like before May. Hopefully. I want to finish this like in April or something like that, so we have time to review the rest. Okay. Okay. Let's continue. So we have limestone and limestone. Basically, this is the reaction in the funnel blast furnace. And when you have high heat, that is generated from the reaction, the combustion reaction between copper and oxygen. You're gonna be able to kind of like like decompose the limestone into calcium oxide and gas X. So gas X is essentially CO2, right? And basically we have silicon dioxide, which is like one of the impurities that we usually have when you extract iron. Because basically, from we extract iron from the ore, and when we collect the ore, there will be a lot of silicon dioxide that can be mixed with the solid. Okay, so silicon dioxide is one the impurity, and we eliminate that because we can have so calcium oxide, right? And we have this reaction that is gonna give you the slag, all right? And like we're gonna extract the slag, which is the upper layer. Basically, when you have the reaction, it will create the metal iron as a liquid and also the slag as a liquid. All right, but the slag is lighter because it has like less density than um, the corresponding iron. So it will be the upper layer. Okay. So can you tell me the like the chemical formula of the slag?
Uh, is CaSiO4.
CaSiO again. SiO what? Almost there. Not
I
O4 actually. If you have CaO plus SiO2, what's going to be your percentage?
um is O3.
Yep, O3, okay. Just based on the reaction. What is the name of that compound?
Uh, is calcium silicate.
Good. Calcium silicate. Um, Explain why the reaction between calcium oxide and silicon phosphide is called the acid-base reaction.
Uh, calcium oxide is the base, and silicon silicon 4 oxide is acid. So when two compare react with each other, it will be acid base reaction.
Yeah, but like it's gonna be the basic oxide and acid oxide, right? The product is gonna give you the salt. The end. Okay. Essentially the basic acid-base reaction. Okay. Um, Describe what happened to liquid iron and slag when they reaches to the bottom of the furnace. I just told you the answer. Can you tell me again what's gonna happen at the bottom of the furnace?
But it will it will less dense.
Which one will be less dense than the other one?
Uh, calcium silicate. It will be less dense, and it can remove from the reaction.
Yeah. Okay. Ca Calcium silicate is gonna be less dense, then it's gonna be removed. All right, and also the liquid iron, which is denser than the slag, and it will also be removed, but like at the different nozzle. All right, let me show you the diagram again. Okay, here. This is the slag. All right, and this is gonna be above. They will be they will both sink to the very bottom of the blast furnace, but it's just that the slag is gonna be less dense than the molten iron, so the molten iron will be extracted at the lower hole, while the slag will be extracted at the upper hole. Okay, let's move on. All right, zinc can be reacted with steam using apparatus shown below. When gas is collected, it's mixed with the air, it will give a small pop. A white solid B remains in the test tube when the reaction has stopped and the apparatus cooled down. So you have this apparatus, you have the rock seal wool soaked in water. Okay, so it's basically um so at this part you're gonna generate the steam for you, and then you're gonna have YB, which is the this is zinc, all right, and then you're gonna have the reaction, all right, and you collect the gas. So this method is used to collect what kind of gas? When you have the test tube that is submerged in the in water, and then you're gonna turn it upside down like that. The gas that is formed will kind of like replace the water in the test tube. So what kind of reaction is that? What is the gas that we will be able to collect here? What kind of gas that we can collect here?
It will not soluble to water, and
Yep, it's not soluble into water. That's it. Okay, the gas that is not soluble in water. Um, So, can you guess what is going to be the product here? What is B and what is A?
B uh, B is iron.
Where's
A
iron? Where's iron in this reaction?
B is zinc.
I mean, zinc
zinc
is the reaction. B is the product. Do you understand? Like this was zinc in the beginning, but then you have steam that is formed and it can react with the zinc at this position. Understand?
uh, So is zinc hydroxide?
Zinc hydroxide. What is the reaction between a metal and the steam?
Uh, oh, zinc oxide,
Mm-hmm. And
zinc
what?
oxide and hydrogen.
Okay, I think that you are still be able to do it. All right, you need to focus a bit more. All right, this is the question that you have, and yeah. So, can you determine what A is and what B is?
So B it will be zinc oxide and A it will be hydrogen.
Mm-hmm. Identify the product formed when gas is burned in the air. When hydrogen is burned in the air, what is it? What is the product?
It is steam.
It's gonna be just water, right? Steam is okay, but yeah, it's just water, right?
Yes.
Okay, that reaction is easy, so I'm gonna skip that. Identify the white solid bit, which is zinc oxide, right? Give the reaction between zinc and steam. We already did that. We're gonna form hydrogen and zinc oxide. Identify another metal which can be safely used to replace zinc and produce another sample of gas A. Identify another metal which could be safely used to replace zinc and produce another sample of gas A. Like the same reaction, but we have another metal. So what is another metal that can also be used?
Is copper.
Copper
Copper.
cannot, like it's gonna react really slowly with water.
Iron.
Iron is okay, yeah. Iron can also be used. Yeah. When zinc reacts with dilute hydrochloric acid, A is produced again. All right, so we have zinc and hydrochloric acid, which is HCl in the aqueous solution. What is going to be your product over here?
Uh, is zinc chloride and hydrogen.
Zinc chloride and hydrogen. Yep. Balance the reaction for me.
We will have two before hydrochloric acid.
Mm-hmm. Okay. So this is moving on to the next part. Students set up the experiment below to find out the condition where it's needed for the rusting to occur. Okay, so I told you we're gonna have four condition, right? All right, give the purpose of the anhydrous calcium chloride in tube D. What is the purpose of that?
Uh, tip D because it's we don't have water, so uh the iron is will not is will it will not rusting.
What is the use? So what is the use of calcium chloride there?
Uh, it will be uh get rid of the water,
Hmm?
the
Get rid of the water, yes. Get rid of the water, right? Because this anhydrous so it can absorb the water. Okay, why do we need to boil the water in tube A?
uh so we will form the hydrogen and oxygen gas.
Hydrogen, how can we form hydrogen and oxygen gas?
No,
By just boil the water.
um, so we just we boil water, so we will form Oxygen gas.
How can we form oxygen gas by just boil the water? If you boil your water, like how can you form the oxygen gas?
No,
You
it's
form oxygen. You form oxygen gas or what?
no. We just have the steam. It's
No,
still water.
no,
It's
no.
just steam.
I explain. Get rid of what?
Uh,
Get rid of what? It's almost correct. Get rid of what? Okay. Can you guess why the rusting does not happen in reaction A?
uh, because they know uh they know oxygen.
Okay. So based on that, to explain why you need to boil the water.
So
What? So if you boil the water, you kind of get rid of what?
oxygen.
Why? Because the solubility of the gas will decrease. All right, it will lower the solubility of oxygen. Solubility of oxygen in the gas. All right. So when you boil the water, what is the observation that you see? Until when you boil water normally, what is the observation that you see?
Uh, is it will form the steam, the gas.
It will steam the gas, right? We also have the steam, but we can also have the gas. You see a lot of bubbles there, right? That is because when you boil the water, the solubility of the gas will decrease and then it will be converted back to the gas, right? We have this dissolved gas in water, and then when you boil it, it will be converted back into the gas again and it will be eliminated. So that's the reason why we need to boil the water, right? To eliminate all the dissolved oxygen in the water. If you still have dissolved water, oxygen in the water, it can still rust your iron. Okay. Okay. So can you explain why we need a layer of oil in tube A?
Uh, so there will be no oxygen can get through the layer.
Yep. No oxygen can get through the layer of oil. Identify which of the test tube contain the air. Can you base
Uh,
on the image above and tell me which one will have the air?
C.
Why? You just read the name. You just read the name of the test tube.
If it contain air. So it's just like uh the iron is left outside and there will be air reactive.
Which test tube? Do you understand the question? Like which one?
The C.
C? How about D? We have the air
Um,
here, right?
yes.
All right. We have the air here as well. Okay. Do we have the air in the salt water?
Mm, yes.
Hmm. So which test tube will contain the air? It's gonna be what? B, C, and D, right? We all have the air here. So B, C, and D. So which test tube contain the water? We have A and B, right? Which test tube contain the air and water?
Air and water.
Air
Uh,
and
B.
B. Which test tube? in which the nails will not rust?
A and D.
A and D. How about C?
C.
You have the air, but do you have water there?
No.
No, so will rust?
No.
No, right? So we have A, C, and D. Okay. Can you explain why we add salt into the water in B?
Uh, if it increase the speed of roasting.
Yep, that's correct. To increase the speed of rusting. Okay. All right. I think that this is enough for today. I think that you are pretty tired now, so we can wrap up the class now. Okay. Thank you. There any other questions?
No.
Okay. Then we can stop here. All right. See you.
Yes.